Good day everyone, I'm Pau, backend engineer, and this is Dev Between Layers. In this episode, I'm going to share with you a symmetric encryption solution that I have built to protect sensible information when sending data from a frontend to a backend. As you have seen in previous videos, I split my workflow system project in two parts. A UI side that allows us to create the workflows, and a server side to store them and later on execute its automation from this other workflow tab template. However, at the time of creating a workflow, there are sensible parameter values you don't want to send through the internet. Let me show you what I have done to overcome that here. We will do the same we did in our first episode. We will just create a workflow with name register and select the Slack channel message action, and we will just send a dummy test message, and this channel ID will be this one from here. We will just copy it here on the downside, and we will take a bot user token from our Slack API and we will paste it here. Let's click to the add action button, and here, as you see in the preview, this is the message that we have pasted. This is the Slack channel that we pasted also, but here in the Slack token ID section we don't have the value we just pasted, but instead we have some hex encoding data, an object with two parameters, an encrypted data, and also an initialization vector. I will explain to you what this data means afterward, but for now we will just click preview and save. This is the way our workflow will be stored in the backend. We will click save workflow, and then in the workflow executor tab we can just select our register workflow, and here in the request body we won't send anything. We will send an empty body. Let's click execute workflow. Here it says success, and when going to the channel we selected, here we have our message. Okay, so the question now is, how is this handled from behind, right? So let's go to our project. This is the data we stored, and as we see it's the same that we saw in the preview. And here the question is, how do we know which parameters for each action should be encrypted or not? Okay, so the answer to that is inside our actions.yaml file, where we specify the, let's say, the behavior of each one of the parameters on our actions. As you see, I have added an encrypted field that says whether a parameter should be encrypted or not, and this is the way the front end and the back end knows which parameter value should be encrypted or decrypted. Okay, so now the question is, how do we encrypt this information, right? So I have created in the website of my application an encryption.js file with an encrypt function, and this function will just take the text to encrypt, and with the help of an encryption key that we will store in our .m file, we will just encrypt the value. At the same time, we need a decryption method in the server side of the application in order to decrypt this information and doing the steps that we applied in our encrypt function. We also need to use an encryption key, and this encryption key must be the same that we store in our in the client side. So as you see here, I have two .m files, one for the server side of the application, which has this value, and the same for the web side of the application, which is down here. It has exactly the same value. Okay, so now the question is, which encryption algorithm do we use to do the encryption? The one that I have chosen is the AES 256 CBC algorithm. AES stands for Advanced Encryption Standard. The AES is a group of algorithms adopted by the US government for symmetric encryption. The 256 is the number of bits that the encryption key must have, otherwise the encryption algorithm returns you an error. So 256 bits is 32 bytes, and this is the length of the keys we have here. On the other side, we call it also CBC because this is the actual algorithm type from the group of the Advanced Encryption Standard. I won't get into the details on how this cipher blockchaining encryption works, but all I can say is that it divides the data you want to encrypt in blocks of 16 bytes, and then if your data is not multiple of 16 then we use a padding strategy, which means that here down there we specify a padding strategy, and what this does is if your data does not have 16 bytes or a multiple of 16, then we fill our data to encrypt with padding placeholder bytes, let's say, until we have the required 16 bytes or multiple of 16. Okay, so as we have said, this algorithm is a symmetric cryptography algorithm, which means that we are using just one key, this key over here, as opposed to asymmetric cryptography, which involves using public and private key pairs. Okay, so how do we prepare the data to encrypt our information? First, we create the IB, which is an initialization vector. This vector will be unique for each one of the parameters that we want to encrypt, and we will just create it randomly. Here, a word array object is created, and this is basically an array of bytes specific to perform the operations inside the algorithm. And we do actually the same for our encryption key. At the time of encrypting our text, we just feed the encrypt function from the crypto.js library with all this information, specifying the algorithm that we want to use, and all the information in byte array format. And then this encrypted object contains the cipher text that is the encrypted data that we later on will store in the workflows.yaml file. As you see, here we have an object of two information, the IV and the encrypted data, which is the information that we are returning here, right? And we decided to store it with hexadecimal encoding format, both the initialization vector and the encrypted data. Okay, so once we encrypt the data, the question is how we do decrypt it from the server side, right? So we will just take this encrypted object that we store here, and we will follow the same procedure. We will take the initialization vector, we will transform it to a byte array, taking into account that we store it in hexadecimal format, and the same for our encrypted text. In the server side, we are not using the crypto.js library, which is written in JavaScript vanilla, but instead we have to use the crypto native library from Node, which is written in C++, and it's faster. But here, as you see, the process is the same. We prepare the initialization vector and the data, and then we feed the cipher function with the implementation of the algorithm we want to use. We also use the same key we use for encryption, but also we prepare it in byte array format, as we did right here. Here, as you see, we prepare the key in the form of a byte array in hexadecimal format encoding, and then we execute this create the cipher IB, and this decrypted variable results in the data that we pasted in the UI. This decrypt function is used in every one of the actions at the time of executing a workflow. So for instance, if we select the Slack.js action, here as you see we are selecting, we are using a getAction object, which extracts the specific information of each action for a specific workflow, and here down there we check which one of the parameters is encrypted, and we execute the decrypt function in the parameters that are needed and store them in the result. So yeah, this is the way we can perform encryption and decryption from the front end to the back end. Now, one question that may arise is, okay, so how do we generate this encryption key, right? The way that I have done it is creating in the server side of the application a generate key script, and here I have just created a makefile to be able to call this script automatically. So here in another tab, if I go to my server side of the application, I can just execute make generate key, and here as you see I'm calling the generate key script, and it's returning me a random 32 bytes key that I can use in these environment files. Now, one thing that I want to point out is which are the problems that may arise when trying to perform this implementation, because as you see, for the encryption I have to use the crypto.js library, whereas in the backend I have to use another library. And this may happen, right, because your front end and your backend may be written in different languages, and therefore the libraries that you use are not the same. This may arise interoperability problems if you don't know what you are doing at every step of the encryption, right? So the problems that I have encountered when trying to encrypt the information with one library and decrypt it with another are related to interoperability. That is, making sure we use the exact same algorithm in both the encryption and the decryption. So here, as you see here, I'm saying use the AES algorithm with CVC implementation and with this padding, and here in the decryption I'm doing the same. I, I am using this algorithm with this kind of padding. But not only taking into account that is important, but also the initialization vector and the key should be encoded in the same way in both implementations. So here, if I'm creating the byte array and the key using the hex encoding strategy, then in the decryption I must do the same. So these two lines here, these two lines in the decryption phase and these two lines in the encryption phase are exactly the same. And the same for the other parts of the function implementation, right? So that's it. If you find this content useful, click the like button and subscribe to this channel. Don't hesitate to share your knowledge in the comments below. As always, thank you for your support and thank you for listening.